Welcome to qnawire.
Factorize fully 9x to the fourth power minus 21x squared y squared plus 4y to the fourth power. We notice that the polynomial contains two perfect square terms, 9x to the fourth power and 4y to the fourth power. So we will attempt to factor this expression by completing the square. To use this method, we need to manipulate the expression to include a perfect square trinomial in the form a squared plus or minus 2ab plus b squared, which can be factored as a plus or minus b squared. In these trinomials, a and b may be variables, constants, or products of variables and constants. In this example, if we take a squared to be 9x to the fourth power and b squared to be 4y to the fourth power, then our value of a is the square root of a squared, which is equal to 3x squared. And our value of b is the square root of b squared, which is equal to 2y squared. Then our middle term is equal to 2ab, or in some cases, negative 2ab. 2ab comes out to 2 times 3x squared times 2y squared, which is 12x squared y squared. In our next step, we will introduce the 2ab term into the original expression, while also moving the negative 21x squared y squared term to the end of the expression. For any term we introduce into the expression, we must add the same term with the opposite sign. This way, we are effectively adding 0, which does not change the polynomial. In this case, the 0 gets added to the polynomial in the form of 12x squared y squared minus 12x squared y squared. Our expression with these new terms is 9x to the fourth power plus 12x squared y squared plus 4y to the fourth power minus 21x squared y squared minus 12x squared y squared. We can now factor the first three terms as a perfect square trinomial, giving us 3x squared plus 2y squared squared. Then we can combine the like terms, giving us negative 33x squared y squared. Now at this step, we expect to have a difference of squares. However, 33 is not a perfect square. When this happens, we can try forming a perfect square trinomial with a negative 2ab term instead of the positive 2ab term we chose. So we will erase a bit of our work to return to the previous step. We proceed to change the sign in front of the 2ab term to a negative. This means our new expression is 9x to the fourth power minus 12x squared y squared plus 4y to the fourth power minus 21x squared y squared plus 12x squared y squared. Then we again factor the first three terms as a perfect square trinomial, but this time the factors are of the form a minus b. Now, when we combine the like terms, we have negative 9x squared y squared. This is a difference of squares, since the expression within the parentheses is being squared, and 9x squared y squared is a perfect square, specifically the square of 3xy, where a is in the first parentheses and b is in the second parentheses. Following the formula for factoring a difference of squares, we get 3x squared minus 2y squared minus 3xy times 3x squared minus 2y squared plus 3xy. Finally, we need to check whether the resulting polynomials within each set of parentheses can be factored. In this case, both polynomials are prime. So we have that 3x squared minus 3xy minus 2y squared times 3x squared plus 3xy minus 2y squared represents the full factorization of 9x to the fourth power minus 21x squared y squared plus 4y to the fourth power.